Okay, right now I will explain about part 1, which is determine the DOF for this robotic arm. Okay, for the first block below is the first DOF. Moving to the second block is the second DOF for this project. The third one is the third degree of freedom in this robotic arm. And then rotate a bit. Then there is a fourth one, and then moving to the rest one is 5 and 6 degree of freedom for this project. So in order to determine the 6 DOF, it should meet the criteria or fulfill the 6 DOF for the robotic arm, which is it should move forward and backward in x-axis, being left and right in y-axis, and then up and down in z-axis. It also can roll in x-axis, pitch forward and backward in y-axis, and also yaw in circle on the z-axis.
Assalamualaikum. My name is Noorhamizah Binti Mohamed. Metric number D170054. I want to present about the setup of the axis DOF by using the SolidWorks. So, at first, we need to click the reference for determine the axis of the DOF. So, we click the axis. So, we need to click the cylindrical or conical face and then click axis 1 so you can see the axis 1 at the first DOF. And then click the axis 2. You also can see the point 2. Then click the axis 3, axis 4, axis 5, 6, and 7 at the base of the bottom. Next, click the reference for the setup the point for the robot. So, click the point and click the center of base. Then we need to click the point 1. So you can see the point 1, point 2, then point 3, point 4, 5, 6, and then 7 at the base. So next, to set the coordinate, we need to click the coordinate system. At the coordinate system, we can see x-axis, y-axis, and z-axis. So we need to go to the coordinate system 5 and then edit the picture. So we need to zoom in to see the selections. So the blue one is the point 1 at the z-axis. Then we click the OK. For the coordinate system 6, also we need to click the edit pictures, and then the blue one is the point 2 at the y and z axis. Then click OK. And for the coordinate system level base, edit the features, and then at the bottom, at the point 7, you can see for z-axis, and then click OK.
Okay, my name is Shazwan bin Raza and I will explain to you about how to export SURFD. Okay, first thing first, we are going to configure and organize the links of each component. Okay, firstly, we are going to configure the base link. The coordinate system will be the coordinate system 11 base, and the char we will write as 1, and then the join is as follow. For the link 1, the join name is join 1, the coordinate system is coordinate system 5, the axis reference is axis 1, the join type is revolute. Then the chart is 1, and for link 2, link 3, link 4, link 5 and link 6 is all the same as link 1, and we are going to export. Okay, for the joint 1, joint 2, joint 3, joint 4 and joint 5 and also joint 6, we are going to set the limitation of the joint to negative 3.14 for the lower, and for the upper is 3.14, and then for the joint 2 until the joints joint 6 is all the same as joint 1. Okay, and then go to next, and then next export and URDF meshes, and then we save the file at our desired path file, and then we change the name. As for me, I will change the name to Ikmal URDF. Then we click save and okay, and that is all. Okay.
Hi, my name is Muhammad Ikmal bin Mohamed, and my matric number is DE170115. So I will explain how to set up the ubuntu, the solidwork design into the ubuntu to move the robot arm. So firstly, we need to self collision checking. So we check the robot arm first. So for the next part is define the virtual joint. So we name as the map. So mention the frame. So we save it, and then it will be shown into the define joint. So we create a group to easy the moving of the robot arm. So we save as arm, and then we copy join 1 until join 6, and then we paste into the group arm. For the next is for the link, we copy all the link or the join into the link group. For the define robot post, we need to name as the post name as start. So we save it. For the next part is we mention for the post 1. This will to make sure the design at what the moving of the robot arm at for each joint. This post will be copied for the next 3 part, which is post 1, post 2, post 3. So the robot will be moving based on the post. So the next part is we mention as stop. For the define effector, the end effector will name as end effector, and then we set parent group is arm. So the next is the join, the passive join. So we have 6 passive join. After that we have host controller for this ubuntu. So for the host controller, we mention edit the control arm controller. So controller we name as the arm controller. Okay, after that we simulate the gazebo, generate the for URFT that produced from the solid. Okay, for the lastly is generate configuration file. So after we done the design, so we can save for the new folder, which is robot arm, any type of folder. So that's all how to set up using ubuntu.
Assalamualaikum and hi, my name is Mohamed bin Nazri. For this part, I will show the demonstration how the robot arm operates. So what we can see here, this is the planning session. We can find how the robot arm operates based on the pose that we can set on this part. So for the first one, we just click the pose one, and then we click execute to see how the motion or the movement of the robot arm for the first pose one. So and then we click the second one and then execute, and the third one, and then we also execute, and lastly we pause to stop the demonstration. The function of the motion planning to see whatever the robot arm operate and confirm the robot arm to move as well that we are programmed. So that's all for this video. Thank you.